Elasticity of demand. We use the notation of elasticity of demand to study our relationships between price, demand, and revenue. So if we look at, first thing, in order to define elasticity of demand, we have to look at relative rate of change. Relative rate of change is the price change in one over the price demand, or the derivative of our price demand function over the price demand function. Percentage rate of change is just taking that relative rate of change times 1,000. And they just kind of explain what the relative rate of change is here. So we're going to go to our example, and we're looking at gross domestic product. It is expressed as this function, where T is the number of the years since 2000. So we're just going to find the percentage rate of change. So that's going to be 100 times f prime of t over f of t. So what is f prime of t? So it's the derivative of our f of t, which is 209.5. So the percentage rate is 100 times 209.5 over our original function, which is 20950 over 209.5y plus 11,361. Okay, so try match problem number 1. And again, you're just doing the find and not the graph for the percentage rate of change. So now we can look at elasticity of demand. Elasticity of demand, if we let the price equal P and the demand X, it's related to or by the price demand equation in the form of X equals. And then the elasticity of demand at price P, which is denoted by E of P, is the relative rate of change of demand over the relative rate change of price. And I went ahead and brought into my file here from the textbook how that's derived. And when you derive it, you get it equal to P times f prime of P, or the derivative of the f function of P, all over f of P, and it's negated. So let's try a problem. First one, here we have a price demand equation. First thing we need to do is make it say X equals, or put it in f of P. Should be 10,000 minus 500p. So then we define our E of P as the opposite of P times the derivative all over and simplifying that factor out of 500 so you get P over 20 minus P. And let's look at evaluating and interpreting at different prices. So E of 4 would equal 4 over 20 minus 4. And interpreting this, since that's a small number, it means that there's going to be little change. To demand. If price changes. And we call that inelastic. Evaluating the price of 16, we see that that's a large number, so it is sensitive to change. We call that inelastic. And if our price is 10, this means that whatever change in price same change in demand. And we call that unit elasticity. So these are defined down here. Inelastic will be positive but less than 1. Elastic will be greater than 1. And unit elasticity equals 1. So if I have a price-demand equation, determine whether it's elastic, inelastic, or unit for these given prices. So the first thing you need to find is your E of P, which is negative P times the derivative all over our original function. So simplified, it's 2p squared over 1875 minus p squared. So find our E at 15. Equals 0.27, which is less than 1. So this is inelastic. E at 25 will equal 1. So this is called unit. And E at 40, oops, equals 11.63, which is greater than 1. And this is elastic. So you try match problem number 2. So let's see what happens to revenue and compare that to our elasticity of demand. So I imported a graph to show you the different areas. So when it's inelastic or less than 1, then our revenue increases. If it's elastic, our revenue is decreasing. And when it's unit, that's when we're at our max revenue. So let's look at the last problem here. It says we're selling at a price of $21 a pair of sunglasses, and our price demand function is given. If the current price is increased, will the revenue increase or decrease? So we need to find E of P first. I'm going to factor out a 250 from the bottom. And that way this simplifies a lot nicer. So we need to find our elasticity at $21. I find that it's greater than 1, which is elastic. And if you look at the graph, or recall what I said earlier, when demand, or I should say price, is elastic, revenue decreases. So an increase in price would decrease the revenue.